Hello, my name is Keith Rucker. So today we're finally going to be doing some Foundry work, guys. I've been promising this for a couple of weeks, and things have just gotten in the way and haven't been able to do it, but we've drug it all out, and we're going to pour some brass today. And I want to kind of go through the process and show you some of the tools and stuff for molding work and then Foundry work, and just give you a little introduction to some of this stuff. So I got started in this probably 7-8 years ago as part of my restoration work, always needing a little part for this, that, and the other. You know, I've got a foundry I can send things to get work done, but I said, you know, a lot of times it's just a lot quicker if I could do some of the small stuff myself. And I can melt brass, I can melt aluminum. I can't do cast iron. My furnace that I have now won't get hot enough to do that, although I'm looking into building a new furnace that will be capable of doing cast iron as well at some point down the road. But today we're going to be doing brass, and I'm going to be basically doing two different projects. Number one, you saw the patterns that we put together for the drain cock for the steam locomotive. We're going to go ahead, I'm going to need 4 of those total, but I want to get one cast and just kind of try it all out, make sure everything's going to work right, and then we'll probably come back and cast the other 3 later on. But before I cast all 4 of them, in case I need to make some changes to the pattern, I just want to check it out first. So we're going to cast one of those today, and then also the parts for my safe dial. For my safe restoration, we're going to go ahead and cast those today. So I think what I'll do is start out by showing you some of the molder's tools and give a little brief introduction to these. So I'm going to move the camera around here, zoom you guys in so you can see some of these, and we'll talk about some of these molding tools. Alright, so hopefully you guys can see these, and you know, let me start out by saying I got real lucky several years ago. I've been doing, like I say, casting for probably about 7 or 8 years now, and I was really just making do on a lot of these tools here. I didn't really have a lot of these tools to help with my molding, and you know, I was just using whatever I could to get by. And probably 3 or 4 years ago, I can't remember exactly when, I went to a tool meet with the Midwest Tool Collectors Association, which mostly has woodworking tools, but they have all kinds of tools there. And I walked up to one of the tables, and a guy had this collection of molder's tools. And he told me that his picker that picks stuff for him to sell a lot came to him. Always, anytime he finds old tools, he comes to this guy. And he had found at an estate sale or something, I'm not exactly sure, but it was evidently a molder who had retired, and I don't know if they were selling off his estate or whether he sold it, but anyway, he had his collection of tools. And he bought all the tools, the picker did. He sold them to the dealer that I ended up getting them from, and he was selling them piece by piece. And when I saw him, you know, he really wasn't getting a lot of interest on these parts because they mostly sell woodworking tools again at these meets. And I knew what they were, started talking to him about them, and tell him I do some casting and kind of tell him what we do out here at the museum and what have you. And long story short, I ended up buying the whole collection from him, and he made me a pretty good deal. I think I paid like $120 for all this stuff. I can't remember exactly, but it wasn't a lot. And it's basically everything you need, pretty much all the tools here. So let's just kind of go through here and talk about these just individually. So start out over here. This is a collection of trowels, and you know, these are just like a mason would use, but these are for smoothing out in the mold, dealing with the sand. And this is probably one of the biggest used tools in the molding process, and you'll see us and use these. And I've got several different styles. Some of these are actually just worn down to a point, but the points actually come in handy in certain applications. So I got a collection of those. These are what we call spoons, or sometimes they call them double enders, but they just have different profiles on here. Flat and round. Some of them are literally shaped like a spoon. And these are, once you get it in the mold, or pull your patterns out of the mold, sometimes you have to do some repair work in there with the sand may collapse, or you get a little spot. So you can kind of reach down in there and use these to smooth out the inside of those the mold. These are little lifters. These are real handy. You kind of slide down next to your pattern sometime with pulling them. And these are down here called lifters as well. You can kind of slide this down the edge of your pattern and help loosen it up, or even get up underneath it with this hook on the end. You know, this is just a little kind of a pick thing again, just helping to extract your molds as well, or your patterns. And these pieces up here There's a whole bunch of these. A lot of these are homemade. Some of these look like they may have been commercially made, but most of these look homemade. A lot of them are cast. I suspect the molder just made up a little pattern and cast these in the Foundry himself. But these are, again, for helping repair your mold. So if you pull it out and you get a corner that breaks off, you can kind of come in here with some of these little cornering tools and just reshape that. Up here are rammers. This is a big rammer here that I got a couple of these that I've got somewhere or another. They're pretty well used. This is for ramming the sand down. I got a smaller one before I got this one up here. This is one I actually made myself on my wood lathe, just out of a piece of wood. You know, nothing fancy, but you know, it works. And up here we got some sprue cutters and sprue molds. This is for making the hole that you pour through. So this is again just a wooden one that I made on the wood lathe. This is a metal tube. It's tapered. You can actually cut the mold out for your pour hole. And then finally is this big screen back here. This is called a riddle, and this is where you can kind of shake the sand and get a loose layer of sand over that pattern before you really start ramming it out. So again, you know, these are the tools of the trade, I guess, and you'll probably get to see us use these as we start ramming up some molds. So with that said, let's start ramming some molds up and getting some of these molds ready to pour. That's going to be the first step of the day. So we're getting ready to start making the mold here, and this is the actual piece that we're going to ram the molds up in, and it's called a flask. And the flask is the two pieces together as a group. You call it a flask, and again, this is what's going to hold the sand, but it's actually two pieces, and they have a name. And the top piece is called the cope, the bottom piece is called the drag. I'll be the first one to tell you, I always have to look it up and remind myself which one it is, which is why I wrote it on here, because I didn't want to tell you guys wrong. But there is a pretty easy way to remember. The drag is the one that goes on the bottom, because that's the one you're going to drag off the table. At least that's what a lot of people tell me how they remember it. I usually still have to look it up, because I guess I just don't do this enough to commit all this stuff to memory. But these are just some little frames that will hold the sand in, and there's some ridges in here. So there's like a lip on the top and the bottom, so that the sand won't just fall out when you pull this up. And if you notice, there's pins on either side, and there's sockets down here that these go into. And this helps make sure that it always realigns exactly the same. When you pull these apart and put them back together, those pins will go together. I usually mark it, and again, I just kind of use a little V shape, and that way when I put it back together, I don't accidentally flip this thing around 180 degrees, or you can get some really funky parts when you cast it if you flip your pattern around. So that's just a little mark for me to help make sure I line it back up when I put it back together. So we're going to take the cope off and just set it aside for right now. And we're going to start with the drag. And we'll take our pattern, and again, these are the patterns for the drain cock on the steam locomotive, and we had showed these earlier. These patterns were actually made using a 3D printer. Usually I will make my patterns out of wood, but this is kind of a new technique, and one of my viewers, Charles Marlin, kind of helped me out drawing these up in SolidWorks in 3D, and then he has a little 3D printer and printed these out for me, which has saved me a tremendous amount of time in pattern making. So anyway, we're going to start by taking the bottom half, and again, these patterns are what we call split patterns. So, you know, there's two halves that go together and to make the whole part here, and there's more parts here, but these are basically split right down the middle, and half of this is going to be in the cope and half of the pattern is going to be in the drag. We'll separate those out and put them back together. The pattern will be withdrawn from the sand. It will leave a void in there, and that's what we're going to fill up with the metal when we get ready to pour. So we'll start by just laying this down flat. I've got this on a piece of plywood here that I can move around, and you'll see why in a little bit. But we just start by laying the pattern down flat, and then we're going to take the drag and flip it upside down, because again, the part that's down will actually be up when we get through. And we're going to ram this in where the part is in the bottom, which will again be on the top. So it's in the mold. Everything is pretty much ready to go here, and we're going to get ready to start ramming this up. All right, I got you zoomed in here where hopefully you can kind of see what we're doing. So again, the pattern is down in the bottom of the mold here. We got the drag portion of the flask turned around upside down, and the first thing we're going to do is we're going to coat this entire pattern with some parting dust. And this parting dust is just a little fine dust. It looks like talcum powder. Quite honestly, I have used cornstarch for this in the past. This is actually some parting dust that I purchased for doing this, but you just want to put a little fine coating on top of this. And again, this is just in a little sock, and when you kind of pop that in there, you can see it just kind of leaves a little layer, and we're going to do just that. We're going to just kind of coat everything up, and this just helps kind of give you a little release agent from that sand. And I'm doing the whole bottom side of the board as well to help that sand release from the mold when we go to pull it apart. So that's done. Now what I'm going to do is I'm going to take my riddle, which is just that screen, and get my shovel here, and we're going to just take some of this molding sand and put in here, and I'm just going to kind of riddle on a light layer in here of fine sand. We want to try to get just a little bit of fine sand on the top part of this pattern, which will help you get the fine details in there. Now, unfortunately, the sand I'm using here is not real fine and doesn't like going through this mold really, or this riddle real easy. I need a little bit finer molding sand for this, but I'm making do with what I got. And quite honestly, I'm not going to worry about it too much. We're just going to go ahead and start filling this up with sand. The sand I'm using is a commercial made product. I believe it's called Petrobond, and all this is just a fine sand. It has a mixture of some clay in it, and they use some oil as a binder to kind of help it all stick together. And you can freshen this up. When it comes, it's kind of this red color. As you use it, it will turn black. And if you get into a foundry, the sand looks black because they've used it a lot, and you can reuse this over and over and over again. Ideally, you have a machine called a muller, which will kind of break it up and fluff it up for when you put it back into start putting it back in the mold. Unfortunately, I don't have a muller. That's something I'd like to find me at some point in time. If I can find me an old used little small muller, it would be nice to have, but I don't have one right now, so we make do with what we got. So I'm just going to put a good layer of sand in here, about like that. And now I'm going to get one of my rammers and just start packing this sand in here. My pattern is actually, I can see my pattern right there, so I don't want to beat on my pattern, but we want to get this good and tight. And you can flip this over with the edges and get in there around your corners. Alright, that's tight enough for now, and we're just going to keep filling this up with sand. Alright, my goal here is I want to get this packed down where I got the sand is actually slightly above the edge of this, because this is going to actually be the bottom that sits down flat, and we want this to be perfectly flat across here. So I'm going to take just a board here, and we're going to do what's called striking off the pattern. And we're just going to kind of pull off that extra little bit of sand. All right, I got a little low spot right there. All right, I like that. Let me clean this up around here. You know, in a commercial foundry or a place that's set up a little bit better than me, you'd be doing this on a molder's bench. So you basically have all your sand just right down below you, and you wouldn't have to worry about making a mess. It's just going to drop down below you. A lot of these places even have where the sand is in a spout or a kind of a system where you just hold it over here and it just fills the mold up, and you're not having to shovel it back and forth. So set up more for production work than what I am here, but you know, we're making do with what we got. Now I have to be careful because the pattern is sitting in the bottom of this, and I don't want the pattern to fall out when I flip it over. So that's why I have this board up under here, because we're going to flip the whole thing over with the board. You want to help me, Andy? Yeah. So we're just going to roll this over. It's just kind of like such. All right, pull that off, and there you see the bottom of the pattern in here. So I am going to keep using the board. Now I can pick this up. I'm not worried about the pattern falling out of it. So I'm just going to set this back on top of my board here. And now we're ready to ram up the coat. So let me grab that. So the pins go in, making sure that I got my lines lined up over here just like I want. And now what we're going to do, first thing I'm going to do is, a lot of times they'd have a bellows to kind of do, you don't want to use high pressure air, but just kind of blow the sand around. But now we're going to take the top half, and I've got some little pins in these patterns that fit down in some holes on the other side, and we're going to assemble this pattern in here. And this center part here is just where my pour hole is going to be, like such. And again, we have the patterns in here that we'll pull out later, and this will be the pour hole right here in the center. There's a little well in the bottom. That's where the brass will come in, and it'll flow into the two parts. So now we're ready again to take our parting dust, and we want to coat this down real good. And it's real important, particularly when you're joining these two halves together. We got that nice flat surface in there, but we're going to be piling sand back on top of this, and we don't want that molding sand to stick between the two layers. So putting this parting dust on there just kind of makes a little dry layer in there, and it helps us to withdraw these parts from one another. So we're ready to go again. What I want to do is I want to mark where the center of this pour hole is, so that I'll know where to actually put down my sprue cutter. So we're just going to mark that on the side of the flask here, and that will be my reference later on, where I can lay out across and drive down that sprue cutter to cut that sprue hole. So now we're ready to basically repeat the same process, and we're going to ram up the top half here. just using one of my trowels here to get a nice, good, smooth surface here on the top. And now we're going to cut the pour hole. And I'm going to use my sprue cutter. The pour hole is called a sprue. So we kind of just mark on here. That should be right on top of that. And we'll just insert this down into here until it hits the top of the pattern. Right there. Whoop. This hole here is not critical. It's just going to be a place for the brass to go down into the mold. We can actually clean it out after we get through here. And I like to kind of funnel that in there so that I have a good hole to pour into. And we'll clean that out when we pull the pattern apart here, or pull the mold apart, which we're going to do right now. But before I do want to make some little vent holes in here. And the purpose of this is whenever we pour that gas in there, you got all the moisture, you've got the oil and stuff in the mold, and it's going to create some smoke and gases, and those need to be able to escape through the mold here. So I've just got a little piece of wire, and I'm just going to poke some holes in here. I don't want to really go all the way down to the pattern, so I'm just going to mark a thing here, and I'm just going to put a bunch of little vent holes in here all the way around. And again, this just helps the gases to escape from the mold without messing the mold up. And if it does hit the pattern, you may get the brass to actually come up this little pipe, but you can cut those off and grind them off later. It's no big deal. No big deal at all. Alright, so now I think we're ready to separate this. And what I'm going to do is I'm going to just kind of wrap the mold. This helps break your parting line. It also helps that mold or the pattern to be able to withdraw here in a little bit. And I'm going to very carefully lift straight up. And turn that over. And part of the pattern came out over there, part of it came out over here, no big deal. We're going to remove the whole pattern anyway. Again, having a bellows is best for this. Let me move this one over here where I can work on it a little bit easier, reach it. Alright, so I'm going to go grab some wood screws, and that'll help me kind of lift this out. I'll be right back. Alright, so where's my trowel? So I've already see where I got some sand trying to pull up around the edges here. I want to very carefully lift this out. And what I usually do is kind of just shake it back and forth, just kind of ever so slightly enlarge that part in the mold. And then lift it out. Alright, now comes the part where we have to come in here and do our repair jobs. We got this little piece right here. Alright, so this is looking good, and this pattern is pretty much ready to go back together. Let me just make sure. Alright, I see one little place right here. I got a little seam in here that doesn't need to be in here, where it just got down in between there, so I'm going to just smooth that out. Want to make sure I get all that sand out from in there so that it doesn't stay in there, because if it stays in there it will leave a little void in your casting. That looks good. Okay, so these are really ready to go back together, but we have a core print in here for a core, and we need to make the core to go in here, and that's going to basically put a hole through the pattern here, and we'll go ahead and show you how we make that core print, or that core. Alright, so now we need to make the actual core box, or the core, and to do that we're going to use this core box, and this is, again, is a little 3D printed part that has the shape of that void that I want to be inside the casting, and it's a half of it, again, kind of a split, and we'll make two halves and we'll just put them together because this part's symmetrical. So to do this, we're going to make the core out of some sand, but instead of using molding sand for this, I got just some regular old white sand. You know, nothing special about it. It's probably a little more than I need. That should be plenty. And what I'm going to do is I'm going to take some binder here, and this is sodium silicate is what this is. I think the old-timey name for it is water glass, is what they used to call this chemical, because it will pour out wet, but as it over time it will harden and almost into like a layer of glass, is what it looks like. And we're going to use this as a binder, so I'm just going to pour some in here and take a stick, and we'll mix all this together. And we just want to make it a nice firm sand that we can mold, probably just a little bit more. Alright, so we're going to now just take this, put it in the mold, pack it in like we did the other mold, and then we'll strike it off. And with any luck, this is going to come right out of the mold. Ah, it did come right out of the mold. This water glass actually hardens in the presence of CO2, carbon dioxide. And you can greatly speed this along if you have a little bottle of carbon dioxide and just kind of run over it. And I have done that before, and I meant to have brought a bottle out here with me. Same thing they use like in Coke machines and stuff to give the carbonation. You can just kind of flood it with that air, and that will almost instantly harden this stuff to a really hard substance, and it comes right out. We're going to have to let this set up for a few minutes. Alright guys, I got tired of waiting on this, so I went out to the farm and grabbed a bottle of carbon dioxide gas, and we're just going to kind of flood this thing with CO2. And what this does is it just causes a chemical reaction. That's what causes this water glass to harden. You can just leave it out, and the CO2 in the atmosphere will do the same thing, but it takes a while for that to happen. But by simply gassing this thing with CO2, I can feel right now, I mean, that's already just as hard as can be. I'm going to do a little bit more though, because I want I want it to penetrate through the core here. That's probably good. I'll flip that off, and now let's see if we can get this out. There it comes. And I'm going to go ahead and soak this side with CO2 as well, just to make sure it's good and hard. Alright, that feels good, and we need 2 of these, so we'll go ahead and make another. And another thing, I didn't show this on that last one, but I went back and did it after the camera was on. I took a little piece of wire and just kind of put down inside this core, and we want to just kind of bury that down in there. And that kind of gives it some stiffness and helps it to where it won't break, basically. So you're just putting a little stiffness inside that. So pack that in a little bit. And same thing, we'll gas that with some CO2. And let's see if we can get this one out. There it comes. All right, now that we got the 2 core halves, what we want to do is these are pretty solid now. That CO2 really does a good job of hardening that. And what I'm going to do now is we're just going to take a little bit of glue, and we're just going to glue these together. Nothing high tech here at all, guys. And let me zoom you. Well, you can see the pattern there, I think, in the video. The core fits right inside those core prints, and now when we cast this, we'll have that hollow void inside that has that column of sand in there. Alright, so now we're going to put our molds back together, and these will be ready to cast. So before I do, I just want to make sure, one last time, blow them out real good. They look clean. So I got my mark here and my mark here. So we'll just pick this one up, turn it over, and carefully drop it in place. So now this mold is ready to pour. We're going to set it aside, and we're actually going to mold up a couple of more molds here so that when we can do our pours, we can just have them all ready to go. So we're just going to set this over out of the way for right now. Alright, so let me show you a little bit about the setup we got here that we're going to do this in. So I've got my furnace here, and this is a homemade furnace that I made out of a 35-gallon drum. And the lining in here, the insulation here, is nothing but a mixture of refractory cement and perlite, which perlite is just a little natural, it's just little white balls you see in potting soil. But it's an inert material. It's non-combustible. It makes excellent insulation. And basically, I'm just using that refractory cement. Most of that's just lightly packed in there, just enough cement to kind of hold it all together. And I just took my hand and just packed it around there and let it dry. And then after that layer kind of got in there, dried in place, I took just refractory cement by itself, watered it down a little bit, and we lined that whole inside and let that dry and cure for a couple of weeks. And it's now ready to go. And then we have a lid. And again, the lid, I got a sheet of refractory here on the bottom. And same thing, the top has just got that insulation in there. And this covers it up. And there is a hole there that the heat and the gases come out of, but it keeps most of the heat down inside the furnace. So let's see. The burner is again, it's a little homemade job. So just made out of some black pipe. So I start out with a piece of 1.5 inch pipe. This is the part that sucks the air in. There's a hole that goes through here, and it looks like probably, I don't know if that's 1/4 or 3/8 inch pipe, one or the other. So 1/4 inch black pipe, this piece of it goes through here. There's a tiny hole drilled in this, and that just basically shoots the propane straight down the burner. It necks down here to a piece of 3/4 inch pipe, and this front piece you can kind of slide it back and forth on here, and that kind of adjusts the torch end of this coming out. So once I got it set, it's pretty much set, but the first time you use it, you kind of have to bump this in and out to get it just right. And then I just got some fitting coming in here with a hose, and I've got a propane tank behind me with a regulator on it that I can control the flow of propane coming into this. So this pulls the air in. It kind of creates a Venturi type situation where it really blows in there and you're getting some good heat. In the side of my furnace, I have a hole. The hole is a little bit off center so that the flame kind of rolls around in a circle in here. And this is my crucible that I use. Now, a lot of people use a ceramic crucible when they're doing casting work, and that's great. I have used ceramic crucibles, but for doing brass and aluminum, a cast iron pot will do the job. Now, after so many uses, it will start deteriorating because you're just heating it up so hot, but it works good, and that's what I'm going to use. So I've got this little cast iron pot, and I kind of made me a little shank to lift it in and out of the pot with. So these are literally just made out of a set of blacksmith's tongs, and I can drop that down in there and reach down in there and pull this in and out. It's starting to rain. And additionally, for handling this, I got these little holes in the top, and I just made this little loop, and I can actually come in here, hook these on either side, and I've got a way to pick this thing up and handle it. And then using a kind of a pair of tongs, I can dip this, and that's how I do my pour, is just by pulling on the bottom of this. Works very well. So we're going to get this ready to fire up. It is starting to... It is starting to rain a little bit, so I'm going to move this back a little bit from the edge. That's the reason we came out to the museum today, is we're expecting some rain. And obviously we don't want to be doing this out in the rain. So I'm going to move back just a little bit, and we'll charge this up and get her going. Alright, so we're ready to start charging this thing up to get ready to melt. And I've got just a bunch of ingots of brass that I've melted down before. And, you know, we're just basically going to reuse these. I just kind of charge this thing up. I want to fill it up pretty good because we got a good bit of metal we want to try to pour. I got some other little just brass fittings, and there's a sprue off of a part we cast one time before. Actually, that was a lever cap for a plane that I was casting, and it didn't turn out. So anyway, I'm just going to remelt it, and that's probably about enough. Maybe just a little bit more, but not much more. Tell you what, we're just going to start with that, and we may add some more to this once that melts down. So that's pretty much ready to go. So we're going to fire this thing up and let her start cooking. All right, so we're ready to light this thing off. And the way I'm going to do this is I'm going to use the oxyacetylene torch. Normally I just use a little propane torch, a little handheld propane torch. But I left mine at home, so we're going to use this oxyacetylene torch right now. Train always catches me. All right, so now we're going to turn the gas on. When I do, we'll put the torch in there and just fire up. There we go. Once it's burning, I'm going to take my lid and we'll cover it up, and we're just going to let this sit here and cook for a while. Now it's just a waiting game. Usually on brass it takes it 20-30 minutes for it to actually melt down enough to start working with. It's been cooking now about 30 minutes, and it's really rolling. See down in there, it's glowing red hot. I can't get you over there really to see the metal, but it's starting to melt. It's not completely melted yet, but it is starting to melt down in there. But it's really cooking. All right, guys, we are about ready to do the pour. This has been cooking for almost an hour. I will tell you that off camera, probably about 30, 35, 40 minutes into it, we pulled the top off, and I actually put a little bit more brass in there. So, you know, we kind of had to, we let what was in there melt down, and I want to make sure I got a good charge, so we added some more. So it took some extra time for that to melt down. Probably would have been about 45 minutes to be ready if we hadn't added that extra metal. But it looks like it's about ready to go. So just a couple of words here. First off, safety. I'm wearing leather boots. I got on long pants, and I'm wearing cotton pants. You don't want to wear nylon, because if anything splashes on it, cotton won't melt and stick to you. It'll actually retard stuff a lot better than nylon or something. Got on long sleeves. I'm going to wear a face shield while I'm doing this. This is a polycarbonate. So yeah, it'll melt if it gets hot enough, but it's not just plastic. And I got gloves. So, you know, we're going to try to be as safe as we can. The plan is I'll shut the gas off. we'll take and remove the lid. I'll come over here, pull the pot out of there that we have the crucible out. We'll real quickly kind of skim the top of that to get any scale and stuff. I'll just kind of rake it to the back, and then we'll come over here and hopefully have enough metal to pour all 3 flasks. We'll just have to play it by ear. We're going to start with the biggest one here and go back. Any extra metal that's left over, I've got a little cast iron. It's a cornbread pan is what it is, but I can pour that brass in there, and it makes nice little ingots to remelt later on. So we're ready to go, so let's do it. I'm going to go ahead and try to skim this before I pull it out. I'm just raking any of the little solid stuff that's floating on the top, kind of to the back of the pot, to try to keep that from pouring in. And that is heavy. All right, Andy. Grab that side right there. We'll come over here. Alright, so we've been letting these flasks cool down for probably about 20 minutes or so. I mean, they're still hot, but they're cool enough for us to go ahead and knock out. So let's grab the other side of that one and we'll set it up here. What I've got here is we just got a wash tub with some boards across it, and we're just going to let all the sand drop down in the bottom. So, you know, we're just going to start ripping this thing apart and see what we got. So, that doesn't look half bad. Let's knock this sand out. This is still very hot, so we're being real careful with it. Just kind of. I tell you what, it's got all the stuff on the top. We're gonna have to flip it over. All right. Got a little bit of cooling on the stem up here, but all in all, I think that's going to be a usable casting. Well, didn't quite fill in there, but we may actually be able to, that's just a little part to grab a hold of. We may be able to fix that even. We'll see. Alright, that's the safe dial. And again, I think that's going to be a usable casting. That one there's got problems. So now, guys, we get to do the post-mortem and see what we did right and what we did wrong. So start with the good. So this is the safe dial, and that looks like a very good casting. You know, we'll cut the sprue off here, and that all part there will get remelted. And but we got a real nice looking pattern, or a real nice looking casting there. I'm very pleased with that one. So now that was the good, and we'll call this the bad. It's not terrible, but it's not perfect either. So this part, the valve body, I think is great, and this is hot, so I'm not touching it. And the stem was fine, but if you look right here on the end, it didn't quite fill this part in. So lesson learned. I think that next time I do one of these, what I will do is we'll actually put a riser over here where that metal will go in there and actually go up a riser and pour, and that should backfill in there and hopefully help us fill in this little piece here. You know, in retrospect, if I had to do it over again, I think I would have actually turned this part around where the stem was down on this side and it went out to the end, and probably put a riser on the end. Because what's happening is that metal's going in here, it's going all the way down here, and by the time it gets down here, it's cooling, and it's having a hard time filling in that part down there. But again, with the riser, you kind of have a reservoir of hot metal. It's a nice thick riser that can backfill in there. So I think we can solve that one there. And this one's not terrible. I mean, this is just a little stem that we'll use to pull this back and forth. And quite honestly, I can probably take a little piece of brass and braze that on there, and it'll be fine. You won't ever even be able to tell. So we may try that before we recast this one. We've got to make 4 of these, so I got to make 3 more of them at some point in time anyway. And the main purpose of looking at this one today was just really kind of test it out, see how this pattern worked. So we had the good, we had the bad, and here's the ugly, guys. This is the safe dial and or the back plate, and it just did not feel around the outside there. And I'll be honest with you, guys, I may actually go back and redesign this pattern. I really think now that it should probably be a split pattern similar to how the dial was done, and where it would be pouring in there again like this one here. I think it would feel around there a lot better. And I was a little bit reluctant. It's not generally a good practice to pour directly into the center of your part. It's usually better to pour in a riser or in a sprue and let a tube or a what do you call it, a gate, run over to that. And I was trying to take a shortcut on this one and just do it the easy way. I really thought with it being a small part that I could get away with it, but in retrospect, lesson learned. So again, I think I may have to go back to Charles and see if I can get him to redesign that pattern to go about casting that piece a little bit differently. No big deal. No metals lost. We'll just melt all that down and do it again at a later date. Alright, so quick update here. We took and cut all the sprues off of this, off these parts, ran them through the bead blaster, cleaned them up, and I'm really getting a much better look at them now. So I got the patterns over here, and then here's the parts. So again, probably the one that turned out the best was the dial, the safe dial. The one piece will become that. Man, that's just a really nice casting. And as long as we don't have any surprise voids or anything in there, this should make a real good part. The valve body, again, I think that's a good casting. Real good there. The stem, we got a little issue down here, and again, I'm not too worried about that. I think I can work around that with a quick fix. This one here, again, you know, it just didn't fill out the mold completely, and we're going to go back and redesign our pattern and go about this a little bit differently. So the goal of this exercise today was kind of twofold. Yeah, number one, I needed some parts cast, and we were successful on most of these parts getting them cast, but also it was to test out the 3D printing for using patterns, and I think we have proven that yes, this works excellent. And probably the best thing about it is that these modifications we need to make to the patterns is a very simple job to go in there and do it and just reprint them. Whereas if I had made these patterns out of wood, it would have been a very time-consuming job to turn around and redo the pattern. So, job well done. I'm happy with the results, and we're going to conclude this one. Thank you guys for watching. Thank you all to my many subscribers out there, and thank you for all your comments. We'll talk to you later.